Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On October 15, 1997, the NASA Space Agency launched its Cassini spacecraft from Kennedy Space Center in Florida. A 7-year journey followed, until Cassini finally arrived in the orbit of the gas giant Saturn. For over a decade, the mission has gathered unprecedented data on Saturn and its moons, and the surprises for planetary scientists have far outweighed any confirmation of standard theory. In this episode, Thunderbolt's Picture of the Day managing editor Stephen Smith offers a comprehensive analysis of the Cassini data from the Electric Universe perspective.
Probably the most dramatic thing about the Cassini-Huygens mission was the landing on Titan. As Huygens got near Titan prior to landing, it saw extensive dune fields as well as branching canyons and mountains. When Huygens did touch down, the Cassini team was surprised to find its surface covered in pebbles. But I don't want to get into the Titan phase of Cassini's observations, though. I want to mainly talk about Saturn. Many things about Saturn changed since Voyager 2 flew by many years ago. Saturn's magnetosphere expanded by more than 1 million kilometers, contracted, and then started expanding again. Those strange spokes that were seen hovering over the B-ring disappeared and then reappeared. The so-called dragon storm on Saturn's equator broke up, moved toward the poles, and then moved down to the lower latitudes. The most likely explanation for the storms on Saturn is that they're like sunspots. Just as the sun changes its behavior over the course of a 22-year cycle, the electrical output that connects it with its family of planets varies. If Saturn's dragon storm and ring spokes are driven by the same Birkeland currents that drive the sun, they should get stronger and closer to the equator as the cycle oscillates, and that's just what happened over the past 3 decades. Another surprise to Cassini mission specialists was how energetic Saturn's plasma sphere is. They saw lightning up to 1 million times more powerful than anything ever seen on Earth. Remember, Saturn's very large. Its equatorial diameter is about 121,000 kilometers, but it rotates in only about 10.5 hours, so its polar diameter is only 109,000 kilometers. That difference is caused by flattening because angular momentum pushes its low-density atmosphere outward at the equator. According to some astrophysicists, that rapid rotation, quote, flings cold, dense plasma outward from the inner magnetosphere by centrifugal force, unquote. Colder plasmas accumulate in the outer magnetosphere, and hotter, less dense plasmas cycle back into the inner magnetosphere. In fact, Cassini did detect jets of hot plasma moving back toward Saturn. Mainstream scientists assume that the 37,000 km/h rotation speed is the only mechanism available that can force cold plasma into the outer magnetosphere and start recycling the hot plasma. Coupled with that observation, Cassini found that charged particles were accelerated to high energies. Of course, planetary scientists think the fast ions are sped up by shock waves. The idea that shock waves, or kinetic energy in general, is responsible for high-speed particles is at odds with electric universe theory. They use terms like hot gas, sonic booms, wind, turbulence, blast fronts, but those effects are woefully insufficient when it comes to providing the necessary energies. It's apparent that NASA only sees pressure, centrifugal force, and gas flow when they're faced with these observations. Of course, they're aware that plasma makes up more than 99% of the visible universe, but they don't consider the role that electric charge distribution plays. Instead, a charge-neutral solar system is held up as their only speculation. Electric universe theory, on the other hand, argues that Saturn moves inside the Sun's plasmasphere and interacts with its electric field. Planets and moons in the solar system are charged bodies. They aren't isolated in empty space, but connect with each other electrically. Several of Saturn's moons, Enceladus, Dione, and Tethys, for example, all revolve inside its plasmasphere, so it seems obvious to me that they'd interact electrically with Saturn. In fact, an article in Nature from 2007 discussed Saturn's electrical interaction with its moons. Quote, "We conclude that the observed double peak pitch angle distributions of the plasma result from the transport of plasma from regions near the orbits of Dione and Tethys, supporting the idea of distinct plasma tori associated with these moons." Unquote. That kind of statement's rare, though. Electricity is almost never mentioned when conventional scientists talk about the solar system. Saturn emits twice as much energy as it receives from the sun. 90 megawatts of X-rays were detected by Cassini. Even that wasn't attributed to electricity. Instead, they said that Saturn's atmosphere reflects X-rays from the sun, even though the Cassini team admitted that the intensity of the reflections was surprising. The reason, of course, it was so surprising is that they ignored the fact that planets with magnetic fields can capture ionized particles and form electrified magnetospheres. It's the magnetosphere around Saturn that traps and accelerates charged particles. Enceladus is another example that provided evidence for Saturn's electrical nature. Cassini images showed Enceladus with ion plumes at its poles, and they were called bubbly with electromagnetism. Since Saturn's magnetic bubble is its magnetosphere and Enceladus orbits inside it, the moon acts like a generator. As its plasma sheath moves through Saturn's magnetic field, it induces electric currents. Another surprise for the Cassini team was that an ultraviolet footprint of Enceladus was detected in Saturn's auroral oval. Ions from Saturn's northern hemisphere proved to connect with the variable emissions from Enceladus's south polar vents. Cassini passed over what NASA called superheated geysers from the south pole of Enceladus. One of the focal points was the tiger stripes, as they were called, where hot vapor was seen erupting into space. Many anomalies in the plumes jetting out of those tiger stripes suggest to me that the region is experiencing plasma discharges because of Saturn's electric circuit with Enceladus. Of course, Cassini scientists jumped to the conclusion that liquid water beneath the surface must be responsible for the temperature anomalies and the jets, since solar radiation and internal heating are the only energy sources that they can use in their theories. Solar heating is completely inadequate because the moon is so far away from the sun. If solar heating can melt ice and cause geysers at that distance, all the ice moons of Jupiter, which are a lot closer to the sun, would have thawed out long ago. NASA thinks the south pole of Enceladus is warmer than it should be, but it's still minus 260 Celsius. The south pole is also cracked and scarred, and there's several crater chains. One thing about electric arcs is that they can excavate surfaces in ways that can't be duplicated. Grooves and trenches typically have no residue inside them. It's like a claw came down from space and scooped material away. Arcs create rope-like trenches that twine around each other, and those twining trenches were seen on Enceladus, especially at the South Pole. And that's because discharge filaments move across the globe like waves that meet at various angles. Gouges lateral to the surface are not like those from fracturing. Some planetary scientists think that Enceladus experiences what's called a libration, or a non-uniform rotation, because of Saturn's gravitational torque. A libration could produce tidal stress, and it could generate lateral displacement, except one big problem is there is no such libration observed, and no lateral displacements can be seen on Enceladus. It bears repeating that the hot poles of Enceladus were a surprise to NASA. Some investigators, like John Spencer, said, quote, "This is as astonishing as if we'd flown past Earth and found that Antarctica was warmer than the Sahara." So-called tidal kneading as a source of heat fails because the theory has no explanation for why the effect is limited to the southern hemisphere. It looks like the same problems that comet investigators have plagued the Cassini mission. The same shaky theory about narrow surface vents above a subsurface chamber of hot water. There's absolutely no evidence for these vents, either on comets or on Enceladus. Hot plumes move across the surface of Enceladus because they're created by electric discharges. Electric arcs produce the plumes and the trenches as they excavate material from the surface, accelerating it into space. A parallel to Enceladus is the so-called volcanoes on Jupiter's moon Io. Those bright plumes on Io moved many kilometers across its surface in just a few years, excavating material and shooting it upward in these gigantic plumes. The jets on Enceladus originate from the tiger stripe channels, and they look similar to those that are found on Europa as well. The tiger stripes are part of a system of channels on Enceladus that match how electric arcs behave in simple laboratory experiments. As I mentioned, the plasmasphere of Saturn is an electrical environment, causing everything from dark mode plasma discharges to gigantic lightning bolts across the ring plane. Planets and moons aren't electrically inert because they're embedded in the sun's circuit like electrodes in those old-fashioned vacuum tubes. The wires on these tubes are really Birkeland current filaments within the solar system and within the plasmaspheres around planets. Jupiter is similar to Saturn because it discharges more energy than it receives from the sun, but Saturn's output is greater. One of the speculations was that supercooled helium fell out of the atmosphere during Saturn's formation. The resulting kinetic energy must have warmed up the core, as they say. However, the evidence suggests to me that Saturn was once of greater stature. Saturn is the way it is because it's closer to being a star than it is to being a planet. Some astronomers think that Saturn's rings could behave like spiral galaxies. The same forces that create galactic arms might be responsible for the unusual features that rise vertically from the ring plane, as well as oscillations seen in the B ring. Some listeners might be familiar with Carolyn Porco, one of the scientists who's part of Cassini's mission team. She wrote, "We have found what we hoped we'd find when we set out on this journey with Cassini nearly 13 years ago. Visibility into the mechanisms that have sculpted not only Saturn's rings, but celestial disks of a far grander scale, from solar systems like our own, all the way to the giant spiral galaxies." Unquote. On August 11, 2009, Cassini observed the equinox on Saturn when its rings turned edge on to the sun, something that happens about every 15 years. And during that phase, some strange configurations were seen inside the rings, so-called propellers, ridges, and waves as high as 4 kilometers. Since the rings are thought to be about 20 meters thick, those anomalous shapes were a complete surprise to mission specialists, especially a 4-kilometer high ridge rising out of a 20-meter thick ring plane. How do clumps, undulations, and ridges form in the rings? The researchers think that collisions and shock waves cause resonant vibrations, and gravity from their so-called shepherd moons is also said to be an influence. In fact, small moons like Daphnis do move up and down through the ring plane, and they do affect the motion of ring particles. But you know, a much stronger force than gravity is always neglected in their speculations. Saturn's rings and moons are electrically charged, I keep saying. They're electrically charged objects moving through its plasmasphere. Instabilities are inherent in the system and probably contribute to the perpendicular features, since gravitational torque isn't seen acting on the particles. Instead, sine waves, perpendicular braids, and cylindrical arcs are seen. Some are even woven together like those in the F ring. In fact, NASA scientists now think that the oscillations in the B ring are not caused by moons or any other body. Instead, they say waves grow on their own and then reflect back again at the edge of the ring plane. It bears repeating that celestial bodies are immersed in plasma, so they aren't isolated. They're connected by circuits. Most of the time, they're not in equilibrium because they're unstable. The majority of them are moving across plasma filaments in the solar system, in the plasmaspheres around planets, or in interstellar and intergalactic space. Currents in plasma contract into those filaments, and the force between filaments is linear, so the electromagnetic fields created by them are the most powerful long-range attractors in the universe, as well as short-range repulsors. Those magnetic fields are what trace out the spiral arms in galaxies because electric current flows through them, both from the intergalactic circuit feeding the galaxy and from the homopolar motor action of the galaxy itself. The magnetic fields exist because the spiral arms behave like large Birkeland current filaments. Since, like a galaxy, Saturn's ring plane possesses a magnetic field, diachotron instabilities might occur. To conclude this short talk, I'll mention the latest surprise reported by the mission team. Since Cassini will be incinerated by Saturn's atmosphere in September of this year, it was decided to take a chance and send it through the gap between Saturn and the innermost ring. They hoped it wouldn't be prematurely damaged by impacts with large dust particles as it went through there. Surprise! There was nothing there except electrons flying through its magnetic field, and that supports the electric universe idea that the rings are part of a plasma torus that surrounds Saturn.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.